Okay, session number 2. Like I said, Jeremy Daly will be with us, but his session is recorded because Jeremy is located in the US. We didn't want him, to wake up so early, so he decided to record the session. But like I said, after the session, there's a Q&A. So if you got any questions to Jeremy, feel free to ask him because he will be live after the session. And a short introduction about the Jeremy, because he is a true legend. He's been managing the development of complex web and mobile applications for over 20 years, and he's been doing that across the globe. So 20 years in his pocket means a lot. Like Alex, our keynote speaker, he also contributes to open source projects like Lambda API, Serverless MySQL, and DynamoDB Toolbox. It's also great because he co-organizes Serverless Days Boston, and today he's coming to you with his session. So stay with us, and the floor belongs to Jeremy.
Hi everyone, I'm Jeremy Daly. Thank you so much for having me here at Serverless Days Warsaw 2021. It is great to be back at another Serverless Days conference. So today we're going to be talking about optimizing serverless workflows. So let's jump right into the slides because we don't have a ton of time. So my name is Jeremy Daly. I am currently the GM of Serverless Cloud at Serverless Inc. And we'll talk a little bit about Serverless Cloud later on, but Serverless Inc., the makers of the serverless framework. I have done a lot of consulting with companies in the cloud that are building serverless as well as cloud applications. I am a 20-year veteran of this, so I've been doing this for a very, very long time. I started working with the cloud in 2009, and then as soon as Lambda became available, I started working with that in the whole serverless paradigm. I blog at jeremydaly.com. I have some open source projects. I do some speaking, obviously. And I also publish a serverless newsletter every week on Tuesday called Off by None, which kind of highlights a bunch of serverless happenings in the space and news and things that are going on, tutorials, stuff like that. Very interesting stuff that you can follow. And I am the founder and a co-host of Serverless Chats podcast. My good co-host now, Rebecca Marshburn, has joined me, and we have some really great interviews. So definitely something to check out there. I'm also a serverless hero with AWS. So it's a great program that I get to get some insight into what they're working on and also give them a little bit of my feedback as well. Okay, so what are we going to talk about today? So we're going to start by talking about how adopting serverless is just so incredibly easy, unicorns and rainbows, super simple to get started. Hopefully you can hear the a little bit of that sarcasm in my voice, because obviously getting started with serverless isn't that easy anymore. We're also going to talk about how serverless changes our workflows and shifts the responsibility. We'll give some tips for optimizing serverless developer productivity. And then we're going to talk about the next sort of revolution/evolution of serverless and cloud in general. So let's start with this. So a couple of years ago at reInvent, AWS had this slide where they called serverless as an operational construct, or they explained serverless as an operational construct. And the idea here was that certain things like VM on-prem or EC2, or even managing MySQL on EC2, these were things that required more operations. And as you started moving across the spectrum, and you got to these things like Lambda and Fargate and Aurora serverless, these were less operations. But there's something that's kind of interesting that happens here, because it seems as though the more operations you have, the less developer responsibility there was, or the less responsibility there was on the developer. And now there's sort of this thing where as you get to less operations and you start using things like Fargate and Dynamo and S3 and these other ones, while it's great because there's less operations, a lot of that responsibility now falls on the developer. And I kind of call this the cloud know-how spectrum, right? Where basically the less ops needed, the more developer needs to actually understand the infrastructure. So a lot of companies say, hey, we're going to move to serverless, it's going to be easy. And the fact of the matter is that it's not easy. There's a lot of things to consider. And if you look at sort of the typical developer experience for someone new to serverless, they look at that hello world example, something that's simple. I deploy a Lambda function, maybe with an API gateway, maybe even with DynamoDB, super simple, works really quickly. It's like, hey, this is awesome. We can just, go ahead and do this. But then when you start looking at these real world production serverless applications, things, the reality is a little bit different. There's a lot of complicated connections between things. It's a lot about understanding all the different services. And maybe 2 years ago or so now, this blog post was published by, I believe it was by Xavier Lefebvre. I can't say his last name. I apologize for that. But this was this idea of this typical serverless architecture. And you notice here that there are a lot of moving parts. We've got Lambda functions, we've got DynamoDB, we've got Amplify, we've got AppSync in here, I think. You've got all these different services that have to intertwine and connect together. And it does become a very complex system. And so this is sort of me, planning any serverless app that I'm working on, is there's just so many different working parts that you have to really start mapping these things together and understand how all this interconnectivity works. And the other thing about serverless is, while it is really, really great for a number of workloads, there are a bunch of workloads that it doesn't always work on, and that you need to sometimes fall back to containers or maybe to some other, more traditional approach to doing web development. Or application development. So this is something to think about, where serverless might not always be the right choice. And the other thing about serverless is, this is, I don't know if this is a quote directly from Albert Einstein, but the only three things that are infinite are the universe, human stupidity, and serverless possibilities. And that's because there are multiple ways to do things in serverless. For example, there's 3 or 4 different ways in which you can do WebSockets using different services that AWS has. So if you were to kind of come up with what we might call the perfect developer experience or developer environment for a serverless developer, what would something like that look like? So clearly we would want to use familiar tools, right? Trying to learn new things is very, very complicated, and it takes time, and you have to bring your whole staff up to date. You also want to make sure that you have very short code iteration and feedback cycles, because you don't want to have to deploy a CloudFormation stack every time you want to test something. You want to be able to iterate on that application infrastructure as well as the services that you're using, because you don't want to have to try to mock some of these things. And that's why you want to have parity with that production environment. And the idea of having parity with the production environment is saying, look, anything that I run in this test environment should map directly to the way that it's going to run in my production environment. So we have to talk about this idea of the new serverless developer. So traditionally, there were a number of things that a developer had to think about when they were building applications. But a serverless developer actually has to think about a bunch of new things, right? So first of all, let's talk about infrastructure. So this is something that many developers in the past didn't have to think about. So it was usually like, oh, well, yeah, maybe we run on containers or we run on EC2 instances, but I don't have to deal with it as a developer. I just write some code, I check it in, and then my ops people go ahead and deploy that. The business logic that we write, for most developers, I've been writing business logic for a very long time. But now we have to start writing business logic that interacts with these new services, that behaves differently based off of these new services. And in some cases, we have to integrate some of that business logic into the configuration of the services itself. So it gets a little bit tricky there. And we're going to talk more about this. Also, build and deployment pipelines. Some of this stuff is old, like we've been building, deployment pipelines for quite some time, but there are a lot of new things in there. And then finally, monitoring and observability. This is something that we always sort of said, well, that's ops job, right? Like they're the ones who have to make sure that they're making sure the app is up and running. That's not really true anymore. And then of course, we can't forget about application security, but we don't have anywhere near enough time to delve into that subject as well. So let's go into each one of these individually. So let's start talking about infrastructure first. So if you're a serverless developer, you need to learn the managed services. You need to understand their limits, and you have to know what the nuances in there are, okay? So it's not like, everything scales really well, but every managed service is different, right? You're not just writing code, whether that's Node or Java or whatever you're writing. Now you have to think about how these individual services work and how those limits how you might run into those limits. There's also a very changed paradigm here. So we're not talking about Ruby on Rails, LampStack, MeanStack, any of those things that were sort of like, yes, it was a very monolithic deployment. I knew exactly kind of what was happening, what I got to interact with. Now we're talking about interacting with potentially tens of services or more, and all of these different services have different communication methods and different ways that they integrate, and that's something that you have to think about. And then infrastructure as code. For most developers, this is a completely new thing. I think for most, for a lot of operations people, infrastructure as code is a relatively new thing. And this is something that you have to understand. All right, so now let's talk about the business logic side of things. So I mentioned local emulation is really, really hard. So if you have to build in, now it might be easy to test an API locally, or maybe I can mock DynamoDB or something like that. But if I have to mock some sort of a DL queue, a dead letter queue, a failover, or some sort of retry mechanisms or things like that, or streaming kinesis logs or whatever I'm doing, those are really, really hard to duplicate locally. So those are things that we have to think about, how do we build those things? We have to think about stage isolation. So in the past, it was often you just take a code, you build the artifact, that artifact gets deployed. Now we have to be very specific, especially with infrastructure as code. We have to be very specific about what each artifact looks like, what the resources are that are deployed, how those resources map to one another. And that's different for these individual isolated environments that we have to build. The other thing is thinking about hexagonal architectures, right? So this is a way that you can do dependency injection, and you can make sure that when you're building applications that rely on other services, that you can actually mock those services out. Now, again, not necessarily emulate those services, but maybe at least be able to kind of mock a response to some of these different things. And it's just a smarter way to sort of build your application in this distributed world. And then the other thing you have to think about with business logic, and I mentioned this earlier, is this idea of configuration over code. And this is something that Eric Johnson talks about quite a bit. And this is the idea that says, look, you have a lot of configuration as part of these cloud services. And a lot of that business logic actually can go in that configuration now, whether that's transformations, whether that's just the failovers and some of those other things. Those are things that you have to start thinking about. And then when it comes to build and deployment pipelines, so we're now packaging, compiling dependencies, and generating artifacts. And like I said, those artifacts now are usually specific to different stages, and there's a lot of intertwined connectivity between those different things. A lot of stuff that you have to think about. So deployments and uploading and executing CloudFormation change sets, or maybe even API provisioning commands if you're using something like Terraform or some of these other infrastructure projects that will use API commands to do this. So this, again, just something new to think about. And then being able to verify deployments, like running integration and smoke tests, and then thinking through to things like blue-green deployments or being able to do rollbacks. I mean, this gets very, very complicated with a lot of these, distributed systems. And then when it comes to monitoring and observability, if you're familiar with Charity Majors, if you're not, you should definitely look her up. She has a really, really great theory, or what she calls observability-driven development. So if you take test-driven development and the ability to run all these tests, but then couple that with the actual behavior in prod, then you get this idea of observability-driven development. And the idea behind here is that you want to write your application so that you can embrace failure, you can instrument as you go, right? So you want to make sure that while you're writing your code, you're actually putting in observability code so that you can test things to make sure that it's working correctly. And then you want to be able to close that loop by having an observability tool that can capture all those metrics and all that data that you're recording, so that you can actually verify whether or not it's running correctly. And here's the link to that. But what's important about this particular type of observability-driven development is the fact that now you, as the developer, you're the one who is looking at the tools and alerts, because who's responsible for that production code now, right? So you're writing code and you're provisioning the infrastructure. So again, who's responsible for the infrastructure configuration issues? So this all comes down to sort of being part of the new serverless developer and things that you need to know, you need to be responsible for while you're building out these applications. Now, again, I'm not saying it's easy. It just gets very, very complex, sort of where that responsibility shifts. So let's talk about a couple of workflow optimization tips. Not all of these are specific to serverless, just things that will help you optimize your workflow and I think make your serverless development experience a little bit better based on sort of the tools that we're using right now. So things like enabling automatic linting and code formatting. Prettier is sort of a godsend in a code base that you have multiple people touching, because the format is the format's always nice, and you're making sure that you're following certain linting rules, and of course for other languages they exist as well. Unit testing the business logic and not the cloud. You do not need to run unit tests to make sure that two things are connected together. You want to run your unit tests on the logic itself that you're writing, anything unique. The actual interconnections with the cloud, those are things you want to test in an integration test later on down the road. Making sure that developers have sandboxes that mimic production is hugely important. Using trunk-based workflows instead of something like Gitflow, for example, is a much easier way to kind of do deployments and rollbacks, especially if you use some tagging in there. Making sure you run smoke tests and integration tests on any deployment so that you know that what has actually been launched is working. And then sort of a bonus if you can take those smoke tests and integration tests and actually do some blue-green deployments on those. So that way you start shifting traffic and then you can roll back. You can roll back to an earlier version if for some reason there's an issue that is coming up. So some other development workflow considerations, and these are more questions, but just from my experience, things that have worked well, monorepo versus multi-repo. As I've said a number of times, I've tried a multi-repo multiple times. I've never regretted a monorepo, but I've always regretted a multi-repo, especially with, when you're starting projects. A monorepo is just sort of an easier way to get started. In my own personal experience, multi-repos get very, very hairy. Managing secrets and cross-account security, just something to think about, right? As we start to sort of follow the recommendations of having separate environments for all our developers and separate environments for each stage in production, maybe even if we're spinning up things like PR and feature branch builds, those are the kind of things that you need to understand how those secrets are getting access, how do you manage the security, and how do different services potentially communicate across those account boundaries so that they can talk to one another. Shared code and packages. This is something where, again, monorepos sometimes come in really handy. You can use Lambda layers. You can do private NPM. There's reasons to do different ones. You can use GitHub and some of these other things, and sometimes they work and sometimes they're not great, but just something to consider when you're building out your workflows is how are you going to share code? The other thing is adding safeguards to deployments. You want to make sure that you are able to protect your production branches and things like that so that bad code doesn't make its way actually into the deployment. And then again, feature branches and pull request stacks, as part of your CI/CD process is a really, really handy way to make sure that you are is a really good way to make sure that you can test these changes and you're not deploying bad code. And then also partial code changes via versus monolithic deployment. So this is something where even if you're using a monorepo, you might have different stacks that get deployed. So that's something to think about where you don't want to deploy all of your stacks every single time you do it. Like if you're just making a change to a small section of your application, if that's broken up to a separate stack, that can work as well. So again, not a complete set of recommendations here, but just things to think about. And as you kind of go down the serverless journey and start building more of these things, you start to learn sort of what works best for your organization. All right, so let's talk about the serverless evolution/revolution here. There are a lot of really, really cool things on the horizon. Some of them already exist for serverless and sort of changes the way that we are starting to build serverless applications. So there's a segment of these tools, what I like to call pre-configured infrastructure platforms. Now, these would be tools or platforms that essentially have infrastructure already provisioned based off of some assumptions, and then you can go ahead and quickly load code onto these platforms and scale up very, very quickly. And these are very cool. So one of these is the AWS App Runner service. All you got to do is just take your source code or a container image, you just drop it in there, automatically does web applications with load balance traffic and things like that. Very, very cool stuff. Nimbella is a similar sort of service. They just got bought by DigitalOcean, and you can just deploy your code, and it's either packaged as containers or just the code, whatever. But then the platform manages a bunch of abstractions. It's got some cool things with stateful serverless underneath there, all runs on top of Kubernetes. And then IBM Cloud Code Engine, very similar, essentially can run containers or application jobs, and it's all done either as batch code or batch jobs or some of these other things, but it's a fully managed runtime for you, so it automatically scales. These are very, very cool things, and in many cases, this might even fit your workload depending on what it is that you're doing. The other thing that is becoming very, very prevalent, and I'm sure you've heard of all of these, is edge computing platforms. So Cloudflare Workers, Fastly, Amazon CloudFront, or CloudFront Functions, as well as I joke about 2,000 more. There's a lot of people doing these. These are great because they have very low latency compute, so you can do very quick operations at the edge. Great for a number of different use cases. They're globally distributed, so you don't have to worry about someone coming from Australia all the way back to US East 1 in order to do something. Some of them even have some cool KV capabilities, so you can actually save data and replicate that globally as well. But they do have limited execution time. I forget, some of them are 50 milliseconds or something like that. It's very, very low, very low execution time. So it's great for lightweight workloads. So these are like redirects, header manipulations, authentication, any type of header forwarding. Some of this other stuff is very, 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 very good for these types of projects. Again, this could get better, though. These could do more in the future, and hopefully they do, because, again, it's a very, very cool thing. So the other thing is Jamstack sites that are integrating serverless into them. So Netlify and Vercel have been around for quite some time. AWS Amplify is a really good front end. It's got a whole bunch of backend stuff as well. Cloudflare Pages also has some really great functionality there for you to deploy Jamstack and then use workers on the back end. These have awesome features like framework detection. So if you're using Next or Nuxt or something like that on the front end, or SSR or SSG, whatever you're using, they have some really good capabilities to detect that. So they do the SSG, they handle all the deployment management stuff for you. They all have some sort of serverless function that runs behind the scenes. And in the case of like AWS Amplify, for example, you can just deploy a full CloudFormation stack behind the scenes. So there's that integrated back-end capabilities there. And a lot of them are extensible. So you can do a lot of really cool stuff with these things and extend them beyond just what the sort of capabilities are out of the box. So I want to take a second, though, to talk about primitives, right? So if you think about the architect framework, then their HTTP sort of handler maps directly to a Lambda function. Their queues map to SQS, tables to DynamoDB, and so forth. And I'm not just picking on them. Serverless framework, for example, all the functions, those map to Lambda functions. Events map directly to the primitives for whatever those events are, if it's SQSQ or EventBridge or something like that. And then any additional resources you define in CloudFormation. But even things like the Cloud Development Kit, AWS CDK, you have to explicitly configure all those resources and then configure how the primitives works. Now, a lot of the code is gone for you. It abstracts a lot of that away, but you still have to be able to configure those primitives, and then they have some constructs that you can use to kind of group some use cases and minimize the configuration, but you are still provisioning specific primitives behind the scene. Pulumi, same way, custom resources for those primitives or those component resources where you can kind of group a bunch of these different things together. But really, the point of all of these things is you still need to understand and be responsible for any of the infrastructure configuration, and then really for the infrastructure that is deployed after the fact. So still really thinking about, I'm using a Lambda function, I'm using an SQSQ, that kind of stuff. Well, if you're familiar with Sean Wang, known as Swix on Twitter and everywhere else on the web, he wrote something very recently which was perfect timing, and it was basically quoted saying, advancements in two fields, programming languages and cloud infrastructure, will converge into a single paradigm where all resources required by a program will be automatically provisioned and optimized by the environment that runs it. And he calls this a self-provisioning runtime. And there's the link to the blog post that he wrote. And let's talk about some of these self-provisioning runtimes right now. So these are either runtimes or languages. So there's a bunch of people that are experimenting in this space. You've got things like Lambdragon and cloudcompiler.run. You've got languages like Darklang and Wasplang, and then this other thing called Encore. So you have some really, really interesting services that are trying to basically say, just write code, and the system will go ahead and provision what needs to be done from an infrastructure standpoint for you. Well, we've been working on something at Serverless Inc., and we call it infrastructure from code. And here's the idea behind it. We want you to only write application code. We don't want any YAML or configuration files. We want to focus on the use cases and the outcomes, so forget about the primitives. We use a bunch of familiar patterns to define business logic, which we'll show you in a minute. We want to make sure that it automatically deploys and manages the infrastructure to support whatever application you write. And we want to provide a bunch of simple workflows for that. so that you can do development, testing, and deployments. And then also this idea of infrastructure being optimized based on the actual usage of it as it runs on this platform. So this is this thing that we built called Serverless Cloud. I'm going to go through this very, very quickly because I don't think we have a ton of time to go through this. So they're very familiar APIs. Essentially, it very much so like an Express app, right? You just go ahead and define API.get, put your to-do in there, and you can go ahead and run, and return your results back. You've got scheduled tasks, so schedule.every 60 minutes or whatever you want, you can run a function based off of that. You have a built-in data store, so you can do this very cool stuff where you can just do data.get or you can do data.set with a bunch of other superpowers that let you do things like retrieve collections of data and some of that other stuff. We have asynchronous change data capture, so you can actually write handlers that react when something is changed in your database, and that's the serverless database that I just showed you. And it gives you all kinds of cool filtering capabilities as well, so that you don't have to do it on everything. You can just say only on created or only on updated or only on created when it matches some particular key value. We have parameters that are always up to date. So you go ahead and you assign these parameters, and no matter where your service is running in our cloud, you can go ahead and change those parameters. They're immediately updated in whatever is running. And then we tried to build a bunch of really great workflows. So just you onboard by typing cloud, you enter a couple of questions, select a starter template, and you're literally up and running. And you have this high-fidelity sandbox with streaming logs that actually syncs your changes. As you're making changes in your local IDE, it syncs it in less than a second. So this is this code watching stuff here, and it runs really fast. And actually, these slides are a little out of date because we just launched this new one that syncs your code. Like, again, it's less than a second. It's super fast. It's quite amazing. And then you can even import data. You can go ahead and create these JSON files that you can import data, so you can do different, you can sort of set your state of your application to different states and test things around that. And then you can go ahead and type share, and you get these preview environments in, a couple of seconds. You have this your independent preview environment that's completely isolated. It's like a snapshot of your code and data that you can go ahead and share with other stakeholders. You can create as many of these as you want to. And then if you want to push it to production, deploy. Simple as that, one command. Now, of course, you can integrate this with CI/CD and some of those other things, but super simple, especially if you're a single developer and you just want to go ahead and move stuff quickly. And then we have a whole testing framework built in, so all you have to do is just write these tests, use this API, .invoke, and this will actually invoke these tests for you. You can run assertions against them, and it all runs in the cloud, and it actually runs independently as independent units, so you're not messing up it's completely isolated, so you're not messing up whatever live code you might have. We have a very cool dashboard that's associated with this, and it's in public preview right now. So if you want to go and sign up, you can go sign up, get an account, start building, tell us what you like about it, what you don't like about it. Definitely send us your feedback. We'll be super interested in doing that or in hearing from you. So anyways, these are a couple things that I'm working on, my newsletter, the podcast, as well as a couple open source projects, and of course, Serverless Cloud. So I hope you will give it a try, and thank you again for having me here at Serverless Days Warsaw.